Hey everybody, in this video we're going to be working on polynomial indefinite integrals. If you want to follow along, the links to the companion worksheet are in the description below. Also, don't forget to click that subscribe button so you can stay up to date on all the videos that we have coming out from the channel. So when we have an indefinite integral, what we're doing is we're trying to basically find an integral without limits. And so we normally take the steps that we would do with a definite integral, except we have to stop at finding the antiderivative. And so when we have polynomials, we're going to be using power rule for all of these. So oftentimes what's helpful is if you rewrite these as terms with x to a given exponent. So with this first one, we have the integral of x plus 4. And so we want to write this as x to the first plus 4 times x to the 0. And so the question is, well, what gives x to the first as a derivative? Well, that means the power is going to go up by 1. Now, if we stop and think, well, wait a minute, the derivative of x squared is 2x. Well, we don't want 2x, we want just x. So that means we have to have a 1/2 out front, because the derivative of 1/2 x squared is just x. So that takes care of that term, but now we have to look here. What is the antiderivative of x to the 0? Well, the power is going to go up by 1, so it's x to the 1 times 4. Because the derivative of 4x is just 4, or 4x to the 0. But the thing we have to remember is that, what if there was an unknown constant? Well, if we take the derivative of a constant, it disappears. So that means we have to add what we call plus c. And c is just a stand-in for the possibility that maybe there was a number. And right now we don't know if there was or wasn't, but we always put one there, just to be sure. So looking at the second one, here we have the integral of 1 over x to the 4th. Now this is the same as x to the negative 4 dx. Now what gets people in trouble is they often forget that what's 1 greater than negative 4? It's negative 3, not negative 5. And so what would be the derivative of x to the negative 3? It would be negative 3x to the negative 4, because you'd bring down the negative 3. Well, there is no number there. So what we have to do is we have to put in a negative 1/3, so that when the negative 3 comes down, it gets canceled out. And then we add the plus c. Now I'll write this with a radical. So, actually not a radical, but 1 over 3x cubed plus c. The negative simply means that the term goes down in the denominator. So for the third one, when you take a radical, that's the same as raising it to the 1/2 or the 1/3 or the 1/4 power, depending on what the radical is. Since this is the square root, this is x to the 1/2. And so what's going to happen is, when we take the antiderivative, x to the 1/2 becomes x to the 3/2. Now, I'm going to leave 5 out front for now, because these often tend to be a little tricky for people. Because what's going to be the derivative of x to the 3/2? Well, the 3/2 is going to come down, and it'll be 3/2 x to the 1/2. But we don't want the 3/2 there. So what we need to do is we need to put in a 2/3 there, so that when the 3/2 comes down, it'll cancel it away. So now, there was a 5 out there to begin with, and so we'll multiply that in. So 10/3 x to the 3/2 plus c. And this one I'll write with a radical. 10/3 times the square root of x cubed plus c. All right. So now for the fourth one. Now all of these are all pretty much written with x with an exponent. All I have to do is just put a 1 right there. So this means that we're going to have x to the 7th. And so there's going to be, oops, don't need the integral sign, because we can take the antiderivative right away. So this becomes 3/7, so that when we take the derivative, the 7 comes down, leaving just 3. X to the cubed is going to become x to the 4th, and then we have 5/4, and then plus x, Well, we already saw that. That's 1/2 x squared, and then plus c. So with number 5 we have to do a little simplifying. So let me rewrite this as x to the 1 plus 2x to the 0 over x to the 1/3 dx. And so when we split this up, we have x to the first over x to the 1/3 plus 2x to the 0 over x to the 1/3 dx. Now when we divide terms with an exponent, we just subtract the exponents. So this is x to the 2/3 plus 2x, 0 minus a third is -1/3 dx. Now that everything is in exponential form that we want, x is the base, we have an exponent on each of them, now we can find the antiderivative. So x to the 2/3 is going to become x to the 5/3 because we add 1. Now 2/3 plus 1 is 5/3. And what we need is we need a 3/5 out front. Why? Because when we take the derivative, 5/3 will come down, but there's no coefficient there. That means there was a 3/5 there to cancel it away. X to the -1/3 is going to become x to the 2/3, because -1/3 plus 1 equals 2/3. Now, when I bring down the 2/3 when we take the derivative, we should be left with 2. So, what should be out there right now? Well, there's the 2, but if you're noticing, anytime we take the antiderivative, you always seem to have the reciprocal out in front. And that's true here, so that means this is 3/2. That's the reciprocal. So if we simplify this, this is 3/5 times the cube root of x to the 5th plus 3 times the cube root of x squared plus c. Now for the last one, it just says the integral of dx. Now you could think of this as the integral of 1 dx, because there's always an invisible 1 there in front of any constant or any quantity. Now we can also think of this as 1 x to the 0 dx. So what is this antiderivative? All right, well, x is going to become x to the first plus c. Or we could just simplify it and just say x plus c. So overall, what we're trying to do, because this is polynomial integrals, is we want to take each expression and we want to write them as x to a given power for each term. And then from there we apply power rule and add 1 to each of the exponents, divided by whatever that exponent turns out to be. And that's how we find indefinite integrals for polynomials. Thanks for watching. If you liked the video, give it a thumbs up. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the best way to understand something is to do it.